actually contracts as a full unit. So there's something called a motor unit, which is the nerve and the muscle working together to contract all of those muscle fibers or cells. And then when a muscle is about to contract, that nervous impulse is really important. And so what happens sometimes when we get a muscle twitch, we are going to have a response to a brief threshold stimulus. And so there are 3 phases to a muscle twitch. And a muscle twitch consists of something called a latent period. And the latent period is the portion of the muscle contraction that the message has gotten there, but it hasn't actually started to contract the muscle yet. So it's kind of this pre-muscle contraction stage. Then you have your period of contraction and then your period of relaxation. And we all know that muscle twitches can be involuntary. Even though a skeletal muscle is voluntary, we do have muscle twitches that are sent, or the message is sent by the motor neuron to actually contract the muscle without us voluntarily thinking of it. So we've seen a graph before in this unit where we talked about a threshold stimulus and that all or none. And a threshold stimulus is the stimulus strength at which the first observable muscle contraction occurs. Now, that just means that we're going to have some muscle fibers contracting. But beyond the threshold stimulus, the muscle is going to, if you get more of the stimulus strength or that stimulus scent, then it's going to increase in the strength of the muscle contraction. Because you can contract a muscle at the fiber level, the cell level, you can contract a muscle at the fascicle level, and then you can contract the muscle at the entire muscle level. So the force of contraction is controlled by multiple motor units, and that's again that motor neuron and the muscle fibers that is going to be allowing for contraction. So what happens when the force of contraction increases, there's something called summation, and that means that you're going to just basically recruit all of those muscle fibers so that they are going to all contract at once so that the muscle, the whole muscle can contract overall. So here's that same muscle contraction voltage graph that we've seen before, and here's that threshold stimulus. So this below this threshold stimulus, nothing is going to occur. So until it hits this threshold stimulus, then we have our first contraction of a muscle fiber or fibers. And then as more stimuli are sent, we can actually increase the amount of muscle fibers that are going to be recruited to contract that muscle. So we're looking at this threshold stimulus graph, and then we're looking at the actual muscle fibers that are coming into play. So you can see we haven't hit the threshold stimulus here, so no muscle fibers have been or are contracting. And then same with number 2. But once we get to that threshold stimulus, we've got a couple of muscle fibers or cells that are actually contracting. And then as the stimuli increases, then we actually are going to recruit more of these muscle fibers to continue to contract until we finally have many muscle fibers working together. So what we call this is TREPI, the staircase effect, and that is going to be where you just saw the muscle fibers are contracting, then they recruit more and more and more and more, and so the contractions are going to increase because there's an increased availability of calcium, which we know that calcium levels cause, or an increase in calcium levels cause muscle contraction. And then muscle enzyme systems become more efficient because we're going to heat it up, and it's going to increase the muscle contraction. And so we're going to just have more and more of those fibers recruited, and we continue to contract more of the muscle at once. And so, again, here's where the stimuli comes in, and then we're going to have more contraction, more contraction, more contraction, until finally the entire muscle contracts.